Thank you.
Well, thank you very much for having me here today. I think no one really knows me here except Amy, I think. So I'm a postdoc in psychology. I started during the pandemic as well, and it's quite interesting to actually go back to doing in-person talks. So I want to talk a bit about work that I've done on analysing longitudinal data, so introducing two different kind of modelling concepts that are quite useful depending on the kind of data we've got. So, I mean, longitudinal data is everywhere these days, I think, and there's lots of interesting questions that we can answer. And the kind of data that I've used is really two different kinds of data. So we've got those big, massive cohort studies in the UK, such as the Millennium Cohort Study, where we measure children from when they were born for several years, but with multiple times years in between. But then we've also got data from smartphone apps, for example, where we've got really high intensive data, where we can get very fine-grained insights into, for example, mood and how that fluctuates over a day or over even within hours. And depending on that kind of data, obviously, we need different analysis methods. So I want to talk about those two methods, which is first the random intercept crossleg panel model. Some of you might already be familiar with the crossleg panel model, which is quite commonly used to analyze longitudinal data that has been measured at multiple waves, but not at intensive waves, really. So I think it's quite useful for data where you've got 10 waves or less. Anything more than that, it gets a bit tricky to actually get the models to converge because of computational complexities. And one thing that is really useful with random intercept crossleg panel models is that it overcomes one of the limitations of previous crossleg panel models. So with crossleg panel models, we can analyze how variables relate to other variables over time. So for example, how variable one, such as behavioral problems, influence another variable like emotional problems over time. However, there's two types of variation that is captured within that kind of model, and that's between person variation and within person variation. When I refer to between person variation, I refer to differences that occur at the between person level, for example, gender that differs between people, or ethnicity, or also genetic predispositions to mental health problems, for example. But within developmental research, like where I come from, developmental psychopathology research, we're also quite interested in how things change at the within person level. So for example, if a child has got behavioral issues and goes on to develop emotional problems, is there anything happening at the within person level? Like, for example, these behavioral issues lead to problems with peers, which then in turn leads to issues with emotions. And then we really need to make sure that we're looking at the within person effects and not a confine of between and within person effects, as has been common with crossleg panel models. So that important advance of this model is that it decomposes data into two parts, and I'll show that in a bit more detail. But overall, the random intercept crossleg panel models allows insights into a variety of different effects. So first of all, the autoregressive and cross-lagged effects. So cross-lagged effects are what I referred to before, where you've got one variable and how that affects another variable over time. Autoregressive effects are effects where you look at how one variable affects the same variable at a later time point. But then you can also investigate mediation effects at the within-person level and moderation effects, both at the within-person level, across the between and the within-person level. For example, if you think of a moderator that differs between people, like gender, could moderate the association between two problem behaviors, or also purely at the between person level, which might be of less interest to the kind of research I do. That kind of model is implemented both in M+ and in R using Laban. However, moderation analyses are not available there yet. So, as I was saying, the random intercept crossleg panel model decomposes data into multiple components, most importantly a between and a within person component. So we've got our observed data, and first we basically extract the grand means. So these are all the means of all participants per time, and on that figure there, you've got the triangle representing the grand means. But then we've also got the between person component, which is really the part of the model that extracts that information that is varying because of differences between people and accounts for all kinds of stable effects, which also makes it really useful when it comes to controlling for stable covariates that we may not be able to measure in our data set. Like, for example, it controls for ethnicity or stable aspects of the family environment, for stable genetic predispositions. And it does that by using random intercepts to capture which represent an individual time invariance deviations from those grand means, so those means of all participants per time point. And once we've accounted for those between person components, we're basically left with the residuals of after accounting for the random intercepts. And those residuals, so those within person components, they reflect the deviation of a person's surf scores from the expected mean score. So basically, if you've got a baseline level of some kind of issue, but that baseline level isn't stable across the whole time, like at some point you might like increase in your behavioral problems, or you decrease in your emotional problems, for example, which would be captured with those within person components. And then we can fit an autoregressive and cross-lag structure on that part to investigate all kinds of research questions where we are interested in within person effects. I'll briefly talk about an example from my own research where I've used a random intercept cross-lag panel model. Here I used data from the Millennium Cohort study, which is one of those longitudinal birth cohort studies that I was mentioning in the beginning, where we've got data measured at multiple time points, but with quite large time intervals in between. So here we use data from the age 3, age 5, and age 7 wave, and we were interested in the role of harsh parenting in early childhood socio-emotional development. So harsh parenting has been quite widely referred to in the literature as having a negative impact on socio-emotional development, but there's also some theories that refer to reciprocal relations, in the sense that having a child with behavioral issues might also lead the parent to engage in more like harsh parenting behaviors, so which is referred to as the Patterson, coined by Patterson, so the cursive cycle of parent-child interaction. And we really wanted to test this using a method that's actually robust to those within person effects that theory refers to, and wanted to expand it a bit by also looking at hyperactive and inattentive behaviors and emotional problems, as those tend to be a bit like neglected in that literature, particular on like Patterson's coercion model. So very briefly here as a figure of my results, and what we see here is we get a variety of different cross-lagged effects, as well as autoregressive effects, which are not quite as much of interest, but the cross-lagged effects really show that parenting practices such as smacking or shouting may have detrimental effects on children's mental health. But we also find that children presenting with emotional or behavioral issues may place additional strain on parenting behaviors, which really indicates that this isn't a one-way direction. It's a two-way thing, where when we have a child presenting with behavioral issues, we also have to pay attention to the parenting behavior, but also if there's some problem with parenting behavior, we need to make sure that the child is able to cope with those and that parenting behavior is appropriate. We also investigated in that framework mediation effect within the random intercept cross-lag panel model. Particularly, we investigated whether harsh parenting and withdrawal parenting, which is another parenting variable referring to behaviors like sending your child to the bedroom or ignoring your child, whether they mediated a cascade, so a cross-lagged effect from conduct problems to emotion problem, which we actually did find that was the case, because there's a lot of literature finding that conduct problems lead to later emotional problems over time, and parenting of behaviors are one of those mechanisms that might play into that relation on the within-person level. So that was an analysis done on non-intensive longitudinal data, so it's just 3 time points. But sometimes, and especially now with all those all that data that is available to us through smartphone data collection, for example, we might need methods that are more suitable for intensive longitudinal analyses. And here, dynamic structural equation modeling is a really useful tool. It's not too different from the random intercept cross-lag panel model, but it allows for the incorporation of many more time points. So I would say at least 10 time points, but it depends on the ratio you've got between the number of participants and the number of time points. So the more participants you have, the fewer time points you need. For decent power, actually, like for example, if you've got 25 time points, you need around 150 participants to do reasonably complex analyses. So dynamic structural equation modeling combines 3 different types of analyses. That is time series analysis, multi-level modeling, and then structural equation modeling. So within the model where we again get within person cross-lagged effects and autoregressive effects, we can also like take those parameters that we estimate there and put it into a much more complex model within all sorts of different things you're interested in. For example, we can use the within person effects as mediators of between person differences. We can also analyze between and within interactions, however, not interactions at the within person level only, or mediation effects of the within person only. That is not implemented yet. Also, the dynamic structural equation models are currently only available in M+, as far as I know. So that's something that remains for future research to actually implement that in open source software like R as well. To explain that model a bit more, I'm again going to refer to an example because I think it's a bit easier to introduce the model. Here I'm referring to a study that we did on the role of perceived stress and negative affect in co-occurring ADHD and internalizing symptoms. So here, rather than being interested in like long-term dynamics of how one behavior affects another behavior over time, we're really interested in like short-term fluctuations in stress and negative affect and how they might be at play at leading to later anxiety or depression and how they're related to ADHD. Again, at the like those moment-to-moment dynamics are at the within person level, whereas ADHD traits refer to between person differences. So we're comparing people high in ADHD traits to people low in ADHD traits on the continuous scale though. So the data set I use here is part of the SET-PROSA cohort, which is a longitudinal cohort study based in Zurich in Switzerland. And within the SET-PROSA cohort, which has been following the lives of around 1,500 children from when they entered school to now, like they're starting another wave of data collection this year. So within that cohort, they've got a sub-study, sub-EMA study, like ecological momentary assessment study, where 255 participants completed prompts on their smartphones for 4 times a day over a 2-week period. And on those prompts, they completed some questions on their current mood and their current stress levels. And we link those data, the EMA data, to the ADHD traits and internalizing problem data from the larger SET-PROSA cohort. So as I was saying, DSM combines 3 different modeling frameworks. So first, similarly to the random intercept model, we have to perform a decomposition where we extract between and within person effects. So we've got our deviations from our, so basically on the bottom, you see the gray stress and affect circles, which represent the person-specific means, like overall levels of stress and negative affect. But then we also on the upper, I can't use my mouse, I can't really point for some reason, but
it's a split screen. So
oh yeah, here we go. So these circles here, they represent the deviations from the within person-centered means. And on those within person deviation components, we fit a time series model. So here we are predicting stress and affect at a given time point. We're predicting that by stress and negative affect at the previous time point. Important here to note is that those cross-lag autoregressive effects are fixed to be equal over time. So any, like if you're looking at time 1 to time 2, that will have the same effect as looking at time 20 to 21. Whereas in the random intercept model, we have the freedom to let those effects vary over time rather than fixing them. Like we can do both. So once we've got those within person modeling done, we can use those effects for the next part of our model, which is the structural equation part of the DSM model. And basically we can enter all of those different effects that we estimated in the previous part and build a larger model where we're interested in how other factors relate to those within person effects. So in our case, we were interested in whether ADHD symptoms are a predictor of those within person effects, so basically whether they moderate the association between stress and stress and later negative affect, but also whether they're predictive of mean levels of stress and affect. And because we were interested in a mediation effect, we also included paths from stress from all those within person parameters to internalizing problems, as well as a direct effect from ADHD traits to internalizing problems. Right, and what we found was that there was a significant coupling between stress, as well as between negative affect and negative affect, basically indicating that there's a carryover effect. So if someone is stressed at time 1, that person is going to be more likely to be also stressed, slightly more stressed at time 2, or if someone is not in a good mood at time 1, they will be in more of a bad mood at time 2. We also found an effect from stress to negative affect over time. Like again, it's on a moment-to-moment basis. So if you're stressed, you're more likely to later on be feeling bad generally as well. And when we looked at the whole model and on that structural equation model, we found a variety of different things. So first, just to clarify, these our internalizing problems and our ADHD traits were modeled using the latent measurement model. So those are basically all our indicators of the latent measurement model, which you can quite easily incorporate into the DSEN framework. So what we found is that ADHD was associated with higher mean levels of negative affect. So individuals with higher ADHD traits were generally also higher on stress levels, like a general overall level, and higher on negative affect. But then we found an interesting effect of ADHD on stress reactivity. So we found a positive effect both on the within-person effect of stress on later affects, so stress carryover, but also on the effect of stress on later negative affects. So basically, if you're high in ADHD traits, that increases the strength of the association between stress and negative affect. So it seems like individuals with a higher ADHD traits react more strongly to stress. Then we also found that higher mean levels of negative affect and higher autoregressive effects of stress were associated with internalizing problems. So individuals who were showing strong stress inertia were more likely to have internalizing problems, or who were generally high on negative affect. And we found a direct effect of ADHD traits on internalizing problems, which was in effect also mediated by the mean levels of negative affect and by stress inertia. So overall, I just wanted to briefly show these two kinds of modeling approaches. Both of those papers have associated code online available. They're both in the process of being published, but both preprint and code is available. So if you've got any questions about those modeling frameworks, I know that was a very brief introduction. So just let me know. And also if you've got any question, I'm happy to answer.